Hello everyone, this is Rona from eMaint Enterprises, Rona Palmer, and I'd like to thank you for joining us on this month's Best Practices webinar. And eMaint is pleased to put together these sessions once each month and arrange to have different subject matter experts come and share their expertise with each of you, so I'm glad you can be with us today. And I'm very pleased to have with me a speaker who's been with us on several occasions, a very popular speaker, and that's Remco Jonker of Mainnovation. And he's going to be presenting today's topic, Discovering the Hidden Value in Your Spare Parts Inventory. Remco, are you with me today? I see your photo. Are you on the line?
Yes, I'm on the line, Rona. Welcome, everyone.
And thanks, Remco, for putting this together, as always. And I'd like to just do a brief introduction of Remco while people are logging in. And Remco was an officer in the Royal Netherlands Navy for 10 years after graduating from Naval College. He's also an industrial engineer with a master's degree from Eindhoven University of Technology. And Remco has over 20 years experience in maintenance and asset management improvement projects. He's also a former chairman of the CMMS section of the Maintenance Association of the Netherlands. And he's a regular speaker at the International Maintenance Conference and various maintenance conferences, and is the co-author of the book Value-Driven Maintenance. And Remco has agreed to send out a signed copy of his book, Value-Driven Maintenance, to one of our attendees today. So we hope you'll all stay with us till the end of the program. And Remco has agreed to share a copy of his book. Before I turn things over, though, to Remco, just a couple of quick items. I am recording today's session so that you might want to share some of this with your team or refer back to it. I also have all of the phones on mute to assist us with the recording, but Remco has agreed to stay at the end of his presentation till the end of the hour and answer any questions you might have. So please feel free at any time during the presentation to just enter your questions into the questions box at any time, and then I'll read them to Remco at the conclusion of the session. All right, so thanks again to Remco and to everybody out there who's listening, and I'd like to turn the presentation over to Remco. Thank you.
Thank you very much, Rona, and welcome everyone at today's webinar about the discovery of the hidden value in your spare parts inventory. We see that a lack of spares can result in extra costs and also downtime, and an overload of spares destroys company value and is often a hidden cost. But how do you find the right balance? Techniques such as reliability-centered maintenance and failure mode and effects analysis can assist in the structured creation of a maintenance plan. But for spare parts management, that doesn't seem to be generally applied methodologies. Today's spare parts management is one of the processes in asset management where there's still a lot of hidden value. Many companies do not have a clear method of defining whether a part has to be taken into stock, how many parts are needed, and also where to store it. And technicians, as we all know, they like to have spares for every part of equipment. And suppliers, they want to sell as much as possible. Accountants consider every spare part to be wasted money. And the asset or maintenance manager has to make a well-considered evaluation. If there is a breakdown of critical equipment and there are no spares or redundancy, the cost of the losses will be high. And on the other hand, having too many spares in stock eats into profits. This webinar shows how the effect of having spares in stock or not can be calculated using the Spares and Logistics Optimization tool, or SLOT. It will be demonstrated how to make stocking simulations and perform a sensitivity analysis. For example, what would be the effect of taking 2 or 3 spares into stock, or what is the ideal mix of spares of your own stock or stock kept at the supplier side. Case studies show that significant direct savings from reduced spare part levels can be attained. The indirect saving, like cost avoidance, of emergency orders and transportation oftentimes is even higher. This calculation model eliminates intuition or gut feeling from spare parts management and shows where the hidden value of spares optimization can be found. But before we go to the content of this webinar, I'd like to hear the opinion of each and every one of you in this virtual conference room. So therefore, I would like to ask you the question, Is your MRO stores operation a constraint or a catalyst to a reliable plant or facility? A, catalyst, B, constraint. So Rona, would you please open up the poll?
Certainly. Well, please type your responses directly into your keyboard. And what Remco would like to know is your store's operation a constraint or a catalyst? Does it help make your plant more reliable, or does it constrain your plant from being more reliable? And once we get all the people voting, we'll share the results. These results are anonymous, so please just give us your honest feedback. Right, it looks like we have about 70% of the votes in, so I'll leave it open a few more seconds. Please type in your response, either A, catalyst, or B, if it's a constraint. Still coming in. Okay, looks like all the votes are in, so let me share the results. And Remco, what our audience has told us, 58% have said it's a catalyst, A, and 43% B, it's a constraint. Right? Back to you.
Thank you very much, Rona. Yeah, so 58% a catalyst and 43 a constraint. Well, if we look at a small poll that was done also at a conference last year at Reliability 2.0 in Las Vegas, and the publication is from Reliability Web's Uptime magazine, there only 24% said it was a catalyst, and more than 75% of the voters said that it was a constraint. So that's a slightly different view. Still, we see that a lot of people also in this audience see it as a constraint in their current operation. All right, so in this webinar I would like to focus on the following agenda, which should lead you through the webinar. First of all, we will determine what in fact the value of MRO is. MRO stands for maintenance, repair and overhaul items. Then we go to the MRO dilemma. Should we lower the costs? Is it about increasing uptime? Or how do we find a balance? And if we know where to focus on, whether it's uptime or costs, how could we optimize the MRO process? So I call it, let's say, spare part management process or MRO material management process. It's all for the same. When we know how to optimize this process, I will highlight a case study of Boskalis. It's an offshore and a dredging company, and there I will also highlight the stock and logistics optimization tool. And then finally we will wrap up with some lessons learned and the Q&A session, of course. First of all, this is the value-driven maintenance model as it is described in the book, and it says in fact that maintenance and reliability adds value to the overall company result in 4 ways, either by increasing uptime on the asset utilization side, lowering costs, so lowering the maintenance actuals on the right side, complying better to SHE legislation from the top, and on the bottom we see it here, the resource allocation. That's in fact about allocating your internal labor, contractors, but also spares. And Mainnovation looks at the economic value added from all of those 4 value drivers and calculates also where the priority should be. So which of those 4 value drivers is the dominant one? And in this case we are going to focus on resource allocation because spares are also in there. And if we drill down 1 level deeper, we go to the competence model. So here you see the improvement circle, in fact the Deming circle, plan, do, check, act for asset utilization. So if uptime is important, you need to set up service level agreements with production, for example. But if costs are important, then you need to make sure to set up your maintenance budget in a proper way. Translate it into your preventive maintenance program, execute, register your cost and analyze. So that's the improvement circle. We see that reliability engineering is very important because we got the input from production, of course, from this side. We got the input, let's say, from the financial limitations, and we get the input from the legislation to be compliant. And on the lower end, we find MRO supply chain management. That's where the spare part management is. Service supply chain management, about hiring contractors. Skills of people and tools, and also equipment knowledge management. That's everything, the data related to the equipment, P&IDs, things like that. We see that reliability engineering is in fact in both circles. And if we look at the spare part management or MRO material management, we see that it is not only about the spares. It probably mainly is also about reliability engineering, because it starts with setting up the right preventive maintenance schedules. So MRO material management is not only a logistic process, but it's mainly a maintenance and reliability process. So knowledge and experience in maintenance management therefore is key in optimizing your spare part level. So in particular, it's reliability engineering and also planning and preparation related to MRO supply chain management. And these relations need to be implemented and monitored from an overall process overview to ensure continuous improvement. Alright, so now you see where the MRO process is located in the value-driven maintenance competence model. Okay, so let's look at the MRO dilemma. So if we are not able to manage our MRO material management process properly, what happens? What could be the consequences? Well, first of all, we will see that the item catalog or the article catalog is growing, and probably with a lot of different articles, which in fact should be only one. So if one O-ring is described, I've seen in many companies that the same O-ring is like 8 or 10 times in the catalog. The pollution of the catalog in that way is a barrier to do proper analysis. Another consequence is the growth of dead stock, of non-movers. If you don't analyze it, if you don't analyze it properly, then the dead stock will grow, and that will cost money. Waiting for the right spare parts. If there is a stock out, we have a breakdown and we need this specific spare part, it's not there, we need to wait. We have a lot of time lost, but more important, probably also production time lost or uptime losses. Another consequence is maverick buying. So it means that the buying of spares is not done through a pre-negotiated frame agreement or contract with the supplier, but the item is bought in the store around the corner. And you should be amazed how often we see in the daily practice that this is still happening. And finally, we see that there are more rush orders. And as we all know, rush orders cost more money. Alright, so the consequences might be pretty big. But what is in fact the financial impact of MRO material management? To highlight that, I'm opening up the book and we look at the KPI, inventory value of spare parts divided by the asset replacement value. Here you see it. What we find out is that in the process industry, the value of MRO item stock is about 3% of the asset replacement value of the plant. What we also see is that on average 30 to 50% of that stock is non-moving. The average inventory handling cost is about 22%. Usually we use a range between 20 and 25%. And inventory handling is like the energy cost, the insurance cost, the cost for a storekeeper. Those are all included in the handling cost. And it's about 22% of the value of the stock. And because of this, oftentimes the storeroom, the MRO storeroom, is seen as an expensive insurance policy. And therefore it's a trigger for many companies to analyze the MRO material management process critically and to start cost reduction programs as a result. And in itself that is not bad unless it is done without taking into account the reliability perspective. And we see that happening oftentimes. And because of that, it will result in stockouts and jeopardizing of uptime and, well, consequently higher costs. So this is the financial impact of our MRO process. So let's look at the operational impact. Well, we see that spare part or material management for MRO items is very important from an operational perspective, because we all know it has a direct impact on asset utilization. The cost and damages resulting from not having a part of stock because of production losses, for example, is oftentimes a multiple of the cost associated with keeping it on stock. And therefore, this process should balance the stock cost with the potential risk of production losses and damages. Well, and then you could also ask the question, of course, how do we determine this balance? The balance between keeping it on stock or not. So what are the costs to keep it on stock, and what are the risks for not having it in stock? That's what we try to answer in this webinar. And we could say, okay, why don't we just use the logistic best practices that are available out there? Well, we cannot do that. We cannot do that because the MRO items, let's say, are a specific breed. So it's difficult to use traditional ABC segmentation, oftentimes used in the standard statistical inventory control or selective inventory control. There the items are segmented in 3 segments, A, B, and C. Like A items, very tight control and accurate records, while C items, simplest controls possible and minimal records. But those conventional logistics will not do the job because, well, in maintenance we see that the huge number of parts and relatively low number of movements make these kind of standard methods like SIG very difficult to apply. On the other hand, we see that the movement of parts on average is not planned. We call it a stochastic process, so it's unreliable, unpredictable when you need a certain spare part. That's because of breakdowns that can happen and unpredictable maintenance that is necessary. And in the MRP, material requirements planning, it's much easier to schedule in the future. In maintenance, that's not that easy. We also see that there's an extensive and diverse supplier base due to specialized original equipment manufacturers, but also the OPM's original parts manufacturers. And then we have the return logistics of repairables. If we build out a repairable, we would like to track it, follow it when we put it on the shelf, send it to the supplier who's going to repair it, and then we want to see that it's coming back, and then we build it in another equipment. So that whole process must be tracked. It's also a specific MRO requirement or characteristic. And then there's this warranty management and the tracking of serial numbers. So all these characteristics, well, the consequence of the characteristics, in fact, is that we cannot use the conventional logistic best practices. We need to do something else. Before we go in what should we do about it, how could we optimize this process, I would like to raise the following poll with all of you in this virtual conference room. And the question is, what is the status of your own MRO material management process? A, we have closed storerooms and spot-on spare parts data available. We have closed storerooms, but spare part data is not reliable. We got an open storeroom, but still we trust our data, or our storeroom and item catalog are a mess. I would like to hand over to you, Rona, to launch the poll.
Okay, so the poll has been launched, and please type your responses directly into the keyboard. And please let Remco know the status of your current MRO process. A, closed storeroom and accurate spare parts data. B, a closed storeroom but unreliable spare parts data. C, an open storeroom with reliable data. Or D, open storeroom and catalog not where you'd like them to be. All right, so please type your responses directly into the keyboard. We're at about 70%, so I'll leave it open a few more seconds. Okay, looks like we've gotten our responses, Remco, so let me share the results. And what our audience has told us is 13% said A, a closed storeroom, spot-on spare parts data. 21% B, closed storeroom but not reliable spare parts data. 21% said C, open storeroom but they trust the data. And then 46%, nearly half, said our storerooms and item catalog are a mess. Perhaps that's why they joined us today. All right, back to you.
Thank you very much, Rona. Yes, so in general, if we look at maintenance and reliability within the overall business processes is oftentimes a Cinderella process, considered not to be that important. But I would say if you look at this answer, within maintenance, let's say the storeroom and the MRO process within maintenance itself is also a kind of Cinderella process. So we see that our storerooms and item catalog are a mess. It's almost 50% of all people in this audience that are saying that. And if we take it back to do you see MRO stores optimization as a catalyst or a constraint? I think that many of you said 58% as a catalyst, but apparently in your current practice it is still a constraint. So maybe I need to rephrase that question next time, because I would say almost 50% saying that it's a mess, well, means that there's a lot of work to do there. All right, so what kind of work could we do to optimize this process? That's where we are heading now. We have seen the financial impact of MRO, the operational impact. We need to find a balance, but how are we going to do that? Well, the optimization in itself, as we say, is a process. So it's not an IT solution. It's not done through changing roles of people only. It's complete process optimization. And if we do optimization like these, we say old ways need to do it in an integral way, meaning that you start to describe how you would like to work through the processes, translate that to the day-to-day organization, so what kind of roles do we need, translate your process description into your IT system, in this case eMaint, X3, and content is important. So what about the data quality? And especially in this case, measure the amount of stockouts, for example. That should be pretty accurate. And the circle around it is about performance management, making sure that you record the results of stockouts, for example, or a turnover of your stock value into performance management, into key performance indicators. What I'm going to do now is I will highlight each of those different circles, starting with the processes. So if we want to optimize the MRO process, first step is to review the current item catalog. And as we have seen in the poll, like 46%, almost 50% is saying that the item catalog currently is a mess. And I know, because it's difficult to manage it properly, so many people are able to oftentimes create new items, and many duplicates get into the item catalog. Second step is review the segmentation of articles. So we need to make a distinction between consumables, for example, and strategic spares. And then analyze the stock position of the critical articles. Do we want to have them in stock or not? And if so, how many? And there we go to the how much, 4.1. Set stock levels for those critical spares. And also, where are we going to put them? That's 4.2. Do we want to have them in our own warehouse? Do we manage them ourselves? Do we have them managed by suppliers? And then when that is set, we need to do an analysis frequently to really understand what's happening, and to see if the business case that we initially set up was realistic, and if we need to take some further improvement actions. So I'm going through each of these process steps now. First step, review the current item catalog. Make sure that you delete double entries, standardize descriptions and taxonomy, and also enrich incomplete records. So this is usually a teaming approach where you work together with procurement, for example, to complete and enrich the records. And also make sure that the descriptions are standardized. If you see 10 same descriptions below each other of an O-ring with an X diameter, then it's much easier to find the right one instead of all different descriptions of that specific O-ring. Ensure that the registered use of items is pretty close to the actual use of items. So how does the issuing process take place in the warehouse? And what happens, for example, during the after office hours? Then the storeroom manager oftentimes has left the building, and technicians can into the storeroom by themselves, taking the spares by themselves. And then discipline, of course, of registering what has been taken out is very important. And how do we deal with the returning of articles? Make sure that they get, in fact, put back against the work order, and that the stock level is raised with one. So review of the current item catalog, cleanse it, that's a very important step. Second step is to make sure you segment the items properly, because we want to put the effort there where it's most value adding. And we only want to have those spares in stock that are the most critical. So the different segments here have different buying and also storing options. So the spare part criticality here is based in fact on the impact, if we do not have this spare, the impact on production. So if the production stops, or if you have a network that is up, if the spare part is broken down, you don't have it available, the network stops, then it's critical. And on the left side we see the market availability here, market availability. Meaning if I take out the spare and there's a certain lead time to get it in the plant and to build it in. If that takes too long, then the market availability is not good, it's no, and if it is okay, then it's yes. So there we get the segmentation of consumables, non-critical items, critical items, and also strategic items. And with strategic and critical items, there it is a question, of course, who which ones are going to put on stock or not. So the criticality in fact is based on the input from reliability engineering. For example, through the input of RCM analysis, reliability centered maintenance, or preventive maintenance optimization. And the market availability is based on the input from the procurement or purchasing department. And again, this is a team effort, and the segmentation changes in time on both axes. So reviewing is a periodic exercise. More about this segmentation and the possible procurement and logistics solutions later. Now I would like to make a step to a practical case study of Cement Australia, where they applied this matrix in a pretty successful way. So Cement Australia is a company that operates 5 cement production sites in Australia, and they're market leader there. They needed to focus on maximum availability, and the maintenance strategy at the time was to replace instead of repair. And that led to a spare part stock value of about 40 million Australian dollars. Well, the exchange rate is like 0.97, so this is about the same as American dollars. So the different plants in Gladstone, Relton and Candles, they were supported by Mainnovation and Captain Trago. They designed an MRO reduction program, which was mainly based on reliability engineering. So the criticality and things like that and the stock levels were determined through an RCM and plant maintenance optimization program. The criticality rankings and streamlined failure mode and effects analysis, they classified according the MRO segmentation. And that after that exercise and the supply chain optimization, meaning where do we put the spares, do we put them in stock ourselves or on the supplier side, it resulted in a reduction of 20 million, so that's 50% reduction, while maintaining equipment availability. So this is a typical case. If you make the connection properly between reliability, your RCM and PMO analysis, and the stock levels, the logistics, then you can achieve impressive results. Okay, so we made a segmentation. Now we see the segmentation also here on the bottom line of this graph. Let's review the stock position. So the balance between risk or the value destruction and cost is leading in the decision of taking an article on stock or not. And this balance involves risk acceptance by the company or the plant. And the risk of value destruction normally has to be a multiple of the cost of keeping them on stock. And the review and decision-making process has to concentrate on critical and strategic spares, as we just discussed already. And on average, we see that these items account for 20% of the total amount of items and often up to 80% of the stock value. And then the main question, of course, is should we put them on stock or not? So if we go to the next step, we need to optimize the stock levels. And I promise you to dive into the procurement and logistics solutions for this segmentation matrix. For the non-critical items, we could say, well, we do not have any stock. We just buy on demand, right? For the consumables, we say, let's minimize transaction costs, or maybe let our inventory managed by a vendor, reorder point calculations, and economic order quantity. This is about efficiency. On the critical items, we might consider to put them on stock. Make sure that we have ensured delivery contracts, that they are delivered in time. And consignment stock, meaning that the stock is in our plant, but we only pay when we issue a spare part or when we use it. So it's still owned by the supplier. And the integrated supplier is in fact outsourcing your complete storeroom, including the logistics and procurement, to a third-party supplier. And the strategic items, those we put on stock. Those we put on stock. And I would like to show you an interesting case of, I think it's best practice, it's Volvo cars. And they made the following item segmentation. What they did in fact is that all request for material has to go through inventory to make sure it's controlled. So one of the segments was order on request, and the description was, well, the item is not physically in the inventory, but you need to order it through inventory. The minimum level in the CMMS is 0, the economic order quantity is 1. So if someone makes a reservation, the ordering takes place via replenishment. Direct order control. If there is material with the call of contracts and frame agreements and very short delivery times, each material request is automatically translated into an approved purchase order and sent automatically to the supplier. So they adjusted their CMMS system to arrange this. Very, very efficient and also effective. Then there's the pay on use. If we have expensive repairables, there's no usage data available. It's the first year, for example, that we have them built in our equipment. Then they use consignment stock, so having items on location, but they only buy them when the spare is used. It's not the physical Volvo stock. And if this all does not work, then they stock the item. But the best practice, I think, is that the whole inventory process or MRO process is running through inventory, even if the item is not on stock. This is, I would like to emphasize, a best practice that I have seen, which worked really well. So if we know how to segment, we need to determine our logistics scheme. And if we look at the whole supply chain, we see the original part manufacturer here, original equipment manufacturer here, and here is the central store or the local store in the maintenance organization. So on this side, this is within the organization, and this is outside. So we see that there are a lot of chains in this supply chain. And also because of that, a lot of costs are involved. So we need to try to take out as many steps as possible, for example, through vendor-managed inventory, integrated supplier concept, or things like that. Also, the other one is only pay for the usage of an item when you take it from your store, and it's still owned by the supplier. All right, then the next step was the business case. Well, if you set up the business case, calculate the different scenarios, and keep in mind the additional cost for breaking existing contracts if you're going to change, and also additional transportation costs if stock is relocated, and additional costs for keeping stock in prime condition when stock is added. So different ways of calculating the business case. What I would like to focus on now is how the reduction of the stock value is calculated within VDM. So assume that we have a stock value of $14.5 million and the asset replacement value of this company is $1.5 million. Well, here's the KPI, MRO stock value divided by the asset replacement value. We see that the current score is like 0.97 and the best practice is 0.7. So what we are going to calculate is if we are able to lower our stock value to that 0.7 level, the best practice level, what value or cash would bring to us. So we look at the current score. Well, the current score, here we see it, the current score is 0.97. We subtract the 0.7, we divide it by the current score, and then we have the relative change. And then after that we look here at the handling costs, 20% of the total stock value of 14.5 million. What is that from a percentage perspective? And then we see that we have an improvement potential of about 27.8%, and that 20% of the let's say the handling cost of $40.5 million, if we translate that to 1% value, it's about 29K. And that means if we are able to change from this to there, it will bring us about $800,000. And of course only if we do it by taking the reliability into account. But that's how BDM calculates the value opportunity in MRO optimization. Well, as said earlier, this is not a logistic process only. We need to embed the identification of the criticality of spares, for example. We need to embed it in our reliability engineering process map. In fact, it should be part of reliability engineering. And so we perform a criticality ranking from an equipment point of view, translate that to the spares, and then make sure that we identify the right spares for each preventive maintenance task, but also to cope with breakdowns that might happen. It's not a one-time project. You need to embed it in your day-to-day operation, and implementing such a reliability process is a must, in fact. So this is about the process. Now let's look at the IT. This again is an example of Volvo cars and how they register, for example, MTTR losses. So an MTTR loss is a loss that occurs because you think your mean time to repair would be about 1 hour, but because of the fact you have a stock out, the spare part is not there, you had to wait longer, so you lost mean time to repair. And therefore they make it possible to register in a very simple way the material, what we are talking about, and the impact, the losses that occurred. And by doing that, you are measuring in the day-to-day operation from an IT perspective what the loss of not having a spare part on stock has caused. And this can also be, let's say, supported by the eMaint solution, of course. Alright, if we look at IT, then we make a switch to the performance management cycle. The periodic analysis could be supported by a control panel. For example, if we click on MRO Supply Chain Management and we drill down, then we jump into the dashboard here, where we see the KPI of stock value versus asset replacement value. We also see the changes in stock value per month. That's the cumulative stock change. The stock accuracy, so the amount of items that have a stock deviation divided by the amount of items counted. The stock turnover can be measured. It's the stock level divided by the usage per month. The reliability of goods receipts, how many goods were too late, how many were on time, that's green, and how many were too early, that becomes yellow. And the reliability of goods issues is the amount of timely issued items divided by the total item requests. So that says something about the reliability of the warehouse process in itself. So by measuring these performance indicators, you are able to get a grip on the day-to-day MRO business. So we talked about the process, we talked about the content, the data quality, and the cleansing of the item catalog. We also talked about support in the IT or CMMS system and a KPI dashboard. So what could we do in the organizational side, one of the other 5 circles? Therefore I go back to Volvo again, the introduction of the item catalog gatekeeper. That is someone who is managing the item catalog by analyzing it periodically, and enrich it in a controlled way. So he's really the gatekeeper of new item requests. And why does Volvo Cars needed it? Well, without embedding this role adequately, the item catalog will, well, become a mess, as we saw in the poll. It becomes less accurate and also leads to obsolete and unnecessary stocks. So they positioned one item catalog gatekeeper, centralized per site, and made sure that an optimization was done across the different spares and also suppliers. And what does this person do? This person is responsible for judging new items, so whether a new requested item should be added to the catalog or not. Are there alternatives or is it included already? This person creates new item numbers, like the sourcing method, vendor information, stock information. He performs periodical catalog analysis whether the right spare parts are in the catalog. He looks at the stock turnover rate, cost for stock or not having it on stock, and also for non-movers. And he is responsible for a proactive approach in relation to projects. And so reuse of already available items and also standardization, which is very important, of course. So this is in fact the whole optimization process to get grip on your MRO items. Okay, let's go into a case study now. It's Boskalis. Boskalis is it's currently Royal Boskalis, Westminster. They have more than 70 vessels. It's one of the biggest dredging and offshore companies in the world, and they do projects across the world. And each vessel has its own storeroom and is serviced in a complex supply chain management process. So the potential stock value reduction of about 6.5 million has been identified, but each vessel had their own item catalog. So the project's approach that we chose there is to standardize and optimize the item catalog across all vessels. So we need to reduce it from 400,000 items to 150,000 items. Yes, the amount of items involved oftentimes is very big. We needed to improve the item data quality and enrich it, cleanse the catalog but also enrich it, optimize the stock levels, and implement that KPI dashboard, the BDM control panel, for continuous improvement. So the segmentation that we made there is looks like this. The different segments. We had consumables, routine items, fast and slow, incidental items, but the focus here for the analysis was on the critical and later on strategic items. The project approach was in fact cut into different phases. Optimize the consumables and routine items by optimizing the reordering points and the economic order quantity. And if we look at the incidental and critical items, and our translation will be also the strategic items, for those specific items we use the spares and logistics optimization tool. And I want to show you a little bit more about that. So this tool makes it possible to automatically calculate the minimum risk cost for a spare part. It also identifies the most optimal scenario, so number needed on shore or on a vessel. You are able to test alternative scenarios by changing variables like carrying costs, mean time between failure, transport times and things like that. There's a complete report available after you chose your scenario to embed in the day-to-day practice. And different risk costs per vessel can be used. And of course that's based on different production losses. So this could also be applied to plants, of course, or networks. But the logistics are pretty complex and challenging. So there's a supplier delivering to a central warehouse, and then it needs to be transported to the ship. And the ship can be anywhere in the world. So we have central stores on shore, on the land, and also stores on the vessels themselves. And the main scenario variables are the stock costs. How much does it cost to put it on stock on shore or on a vessel? And what are the transportation times? Well, from the supplier to the central warehouse, but more important probably from the central warehouse to the vessel offshore. Right, well the tool looks like this, and now I would like to make a sidestep to this tool. I will go into it in a couple of minutes. So here we see the basic scenario. That's the basic scenario. And on the right side we see the test scenario. So here you can do whatever you want to see what the impact is of what you are doing. So we see the ship name, the MRO carrying cost per ship, the MRO carrying cost on shore, how many of parts are in operation in the fleet, and what is the failure type. Is it normal? Is the failure rate increasing or decreasing? The mean time between failure can be entered here. The delivery time in days, the transportation time, emergency transportation time, also important. Redundancy factor, so if the spare is breaking down, do we have a redundant one? And a lot of other things. And here below we see how many items are required on shore, on the ship, and total. Well, I will not go into all the formulas, of course, but I would like to show you how the tool works. So in this case, there are 4 vessels in the tool. We go to the second tab and we choose the Crestway, which is another vessel. We see the remaining life, the carrying cost, and the downtime cost per hour. Okay, let's go to the third tab here, the MRO analysis. So here we see the same cockpit that you have seen in the PowerPoint, and I'm going to choose another spare, the bearing block. So now we see things changing. This bearing block is also used on another vessel, so we see that there are two in operation. And if we now go to changing the emergency response time, where is it here? We change it from 8 to 24. I want you to look what's happening here. So the transportation time is changed from 8 to 24, and then we will see that the total number of spares required is changing from 0 to 1 in this case. Now I reset the scenario. I'm going to make another change. So the current carrying costs are 43%. If I bring that back to 20%, what's happening then? And look to this cell here. It's changing again. Because of the longer lead time, I need an additional spare, as you can see. I'm resetting the scenario again. Now I could change the carrying cost from 43 to 20%. Let me do that. I'm changing the downtime cost from 800 to 1200, and the mean time between failure is changed from 10,000 to 4,000. And then we will see here that I need also a spare on shore. So that's the most optimal scenario from a risk avoidance, but also from a cost balancing perspective. So again, it's difficult to go into all the logic and intellect that's behind this tool, but I hope that they give you a flavor about the different variables that can be used and how they influence the question whether the spare should be on stock on the vessel or on shore or not in stock at all. All right, let's go back to the presentation. Let's go back to it. Here we were. Okay. So what did we do? We looked at the MRO process and the value. So the value within VDM of the MRO process is in the resource allocation value driver. And we saw that there's a big relation, important relation between reliability and the MRO process. We also saw that the consequences of not handling or controlling the MRO process properly can be big, like increased costs, production losses, so lost uptime. But on the other hand, if we have too much stock value in our warehouse, well, that eats into profit directly too. So we need to find that balance. I hope that I showed you a way to do that through the MRO optimization, the process steps that can be taken, cleansing the item catalog, for example, making sure that IT supports it properly, that you monitor it through a control panel, because in the end that's why we implement those CMMS systems, of course, right, to get the right management information. And also maybe consider, depending on the size of your organization, of course, to introduce the role of an item catalog gatekeeper. I also emphasize the best practice of Volvo cars to ensure that all material handling, in fact, is going through the warehouse. I think that's a real best practice. And I hope that I highlighted it properly by showing you the Boscalis case that had a big challenge in reducing the item catalog from 400,000 to 150,000 items, and also reducing or optimizing the stocks across the vessels and also, well, across the shore. What are the lessons learned then? Well, first of all, optimizing spares must be initiated from a maintenance and reliability perspective, so not by cost reduction only. Major stock reductions are possible. We have seen it at Cement Australia, but also at Volvo cars, for example, and Boscalis. Optimization projects can be labor intensive because the impact, for example, of the item catalog, the size of it is oftentimes that big that it takes a lot of hours to cleanse it. So set priorities and split your project approach and use the item segmentation for that. So make sure you put your effort there where it adds the most value or where you get the biggest bang for your buck. And split the project approach also in phases of optimization. Don't try to do everything at once. Then we see that continuous improvement requires all processes to be in place and also to be monitored through a KPI dashboard, for example. But item catalog management is important to ensure that we can trust the data that is in the system, that we are able to monitor the performance indicators properly, as highlighted in the dashboard. but also that the procurement tasks are carried out properly, and that we use procurement input, for example, to enrich the item catalog. So in itself, it's a process not only for maintenance, it is reliability, and let's say it's maintenance, engineering, but also procurement and logistics. Work together as a team. But reliability engineering determines what is critical, and that's not done by the storekeeper. If you really want to improve yourself continuously, use an effective monitoring system, like configure the KPIs into your eMaint system, for example, or use a dedicated dashboard to really monitor what's happening in the day-to-day business. And if you do that properly, then you will discover the hidden value of your spare parts. I would like to thank you for your attention and hand over to Rona for the Q&A session.
Thanks, Remco. So again, we have about 10 more minutes, so please go ahead and type your questions into the questions feature. And we have been asked about receiving a copy of the presentation. I wanted to remind you there'll be a survey at the conclusion of the webinar where you can request a copy, and we'll also be emailing you with a link to the recorded session. So please go ahead, though, and type in any additional questions. And one question that came through, Remco, is how is the slot system that you're describing different from the RAMS analysis for spare parts rationalization and optimization? Can you touch on that?
Yeah, well, I'm not completely aware of the content of other tools, but if we look at the slot tool in itself, what we try to achieve here is not make sure that the tool in itself is giving you the best mathematical solution. That's in fact not what it's all about. It's all about trying to configure the reality in a reliable program which gives you a certain outcome, but we use it merely as a tool to facilitate the decision-making process, then only prescribing if the tool says you need 2 or 1, that is the absolute truth. So again, if we go into these processes, it's more about using it as a support tool to facilitate the discussion and also make objective decisions, and then make sure that we monitor it properly in the day-to-day operation to see if some assumptions were made wrong, for example, and then make sure that you take an improvement action. So it's merely about facilitation of the decision-making process than relying 100% of the outcome of the IT only. That's not the main purpose of it.
Gotcha. A much more holistic approach. Another question that came through is, earlier on you talked about the calculation of inventory versus asset replacement cost. Can you review that again and share what you feel an optimal value is? Or I think you might have shared several different optimal values depending on the type of industry you were in.
Yeah, let's see. If we go there, let's see. Let's just bring it on here. So here we see the different values of the KPI, the inventory of value spares divided by the asset replacement value. What you see here are averages. So in the food, for example, it's about 2%. In the pharma, it's even 4%. So there's not a real guideline. It should be 3 or 1. It depends on your industry. That's one thing. And we have the average values here, so you can see whether you have more on stock than average or lower. But in the myvdm.com tool, which you see here, it's an online benchmarking and value calculation tool. There we have the information of the best practice value per industry, and also I would say the worst practice value in the industry. All the data in myvdm.com is validated on-site by consultants. So it's not that people are able to fill in data just like that. All data is validated. But I would like to emphasize something else. If you look at the value of spare parts divided by the asset replacement value, if the average is 2 and you are scoring 1%, but your uptime is low and your costs are high, that 1% might not be a best practice. You might have too little spares on stock. If the average is 3% and you have 5% on stock, but your costs are low and your uptime is high, well, then you probably have the right spares on stock. You might reduce it a little bit. What I try to say here is that in itself this value doesn't tell you that much. You always need to look at it from a, well, to the interrelation, the connection with other competencies. And that's also what we try to show here. So if we looked at the KPI of MRO supply chain management, great, we score 1%. But you always need to take the uptime into account and the cost level. And because if the stockouts are very high, then you need to improve that inventory level. So we cannot say, okay, if our, let's go back there, if our value is 3%, we're safe. No, you always have to look at the balance or the relationship to the uptime and cost control.
Great.
All right?
Thank you, Remco, for clarifying that. Can you give an example of, you talked about the gatekeeper, and can you give an example of how many people an average or small size company of say 100 people should plan to have in their inventory department? And if you can also share for a larger company like the vessel example, how many people they had in their department?
Yeah. Well, usually the item catalog gatekeeper, if that person is dedicated to, let's say, gatekeeping the item catalog, the company oftentimes is significant. And if we look at Boskalis, for example, we had about 400,000 items in the catalog, so that's pretty large. And also within Volvo cars, if you look at the stock values, well, that is about a real value, like $40 million. That's what we're talking about. Then it's justified to have that role. Then it will bring added value. But I would like to say something else. It's not about, in my perspective, dedicating it to one person only. Because if you only have 100 people on site, for example, in the whole organization, maybe 10 people in maintenance, one item catalog gatekeeper is too expensive. But from my perspective, it's not about one full-time equivalent. It's about implementing a role. So even if you have a small organization, the role of item catalog gatekeeper could be still performed by one or more people, maybe by the reliability engineer or the storekeeper. So again, it's not per definition about adding one full-time equivalent. In a big company, yes. But in a small company, it's mainly about adding that role to, well, people that are in reliability engineering, maintenance management, or in the logistics operation. So again, you still, in a little organization, small organization, you can add it as a role.
Got you. That's a great point. And then as you grow, you can justify the full-time position. But I think we have time, Remco, for one more question. And a listener asked, in the savings calculation for reducing the stocking levels, how do you factor in a write-off required if you're not able to sell your excess inventory back to the supplier? Does that figure into your equation?
Could you repeat that?
Yes. Do you factor in the write-off required in your savings calculation if you have excess inventory that you're not able to sell back to the supplier?
Yeah, that is included. Yeah, that is included in it too. It's in the formula.
Okay. It's inside the formulas.
Yeah.
And Remco, if people want to get access to, what are the next steps should people want to know more, get more information about this sensitivity analysis tool?
If people want more information, they can just send me an email with a specific question or the request for more information, and then I will take it from there.
Excellent. Okay, and Remco has displayed his email address on the screen, and I'm afraid we're out of time for today, but I do appreciate, Remco, you putting together this presentation. I think it was excellent information. And to all of our listeners out there, there will be a brief survey when we end the webinar, and that's where you can indicate if you'd like to receive a copy of the presentation or have a follow-up from Remco and the Mainnovation team. So there'll also be a question about any other topics you'd like to see us cover in a future webinar. But again, I'd like to thank Remco and Mainnovation for putting together a really in-depth presentation. Thank you, Remco. It's always a pleasure.
Thank you very much, Rona, for hosting us. Thank you very much. We appreciate it.
Okay, and thanks to all our listeners to take time out of your busy day, and hope to see you again the next time. Goodbye.